So, hi everyone. Today I'm going to be presenting some work in progress that I'm carrying out with Nat Santos, who's also in the audience. We're both PhD students at Cornell, and there's our email addresses in case you contact us. The title of the project has changed since we initially submitted the paper, and now we've called it Uncharted Territory, Uptake, Participation, and Real-Time Response in EMA Data Collection. Before I start with the content of the project, I would like to clarify two concepts that I'm going to be repeating in the slides. One is non-participation, which we define as not having submitted any EMA despite having told us that you were going to, and then non-response, which we defined as not answering a given EMA ping at a certain location at a certain time. I'm going to try to catch your attention by directly telling you what we believe is our contribution to the literature. First, our results show that non-participation and non-response can be driven by different processes, and the literature perhaps may be assuming that these are the same. Our results also show that the spaces in which EMAs take place can alter non-response patterns, and these has not been paid a lot of attention to in the literature. And hopefully our results will motivate scholars using EMAs to pay attention to these processes of data collection. So what brought us here? Basically, we all know that EMAs are the source of highly granular spatiotemporal data, but it comes with a trade-off, which is a very large burden on responses. And within that framework, because we know the burden is pretty important, then we should worry about attrition and selection when we are making inferences to populations. We know from the literature that non-participation and non-response in EMAs can be affected by factors that generally also affect other traditional measurement items like surveys, but there may be also factors that are unique to EMAs. For instance, someone's familiarity with the technology that is being used to collect them. And you may wonder, why do we care about the spaces in which EMAs take place? Well, I encourage you to imagine that you get pinged in a track that is known, or in an area that is known for having high violent crimes. Would you pull out your phone and answer a 5-minute survey? So in this presentation, I'm going to focus on two research questions. One is, what are the individual level and residential neighborhood characteristics that shape non-participation? And then, how does real-time response vary across individual characteristics as well as the characteristics of the spaces in which EMA pings are received? To answer these research questions, we use data from the Chicago Health and Activity Space in real time, which consists of a probability sample of older adults from 10 neighborhoods in Chicago that were purposely picked to include a wide range of racial/ethnic backgrounds as well as socioeconomic compositions. And the steps of data collection included a baseline survey, some GPS tracking, and then after that, some voluntary EMA data collection through smartphones that were handed to older adults. We pinged individuals 5 times per day, and these pings were randomly distributed across 5 daily windows. So people could participate up to 7 days per wave, and this yields a total of potential 35 EMAs per person, assuming that they would participate the 7 days that the study took place. In these results, for our analysis, we're going to use complete observations of white, black, and Hispanic older adults in wave 1. We're going to derive their individual characteristics from the interviews that took place, and then we'll gather information about their residential context and the spaces where they got pinged from the American Community Survey, which is this public data source that provides geographic information at different units like block groups, census tracts, counties, etc. So for my results, the first question was about non-participation, which again we defined as having agreed to participate in EMAs, but actually not providing any. So that would be our Y, and here X is just a vector of covariates. That would be individual level and residential neighborhood characteristics. And the main two results from this model are that 21% of our sample, despite having told us that we're going to provide EMAs, ended up not doing it. And then our second highlight, or our second main result, would be that in our fully controlled model, the characteristic that is the only characteristic that is a significant predictor of non-participation is having been the victim of a violent crime. But counterintuitively, how this works is that people who reported having previously been the victim of a violent crime were actually less likely to not respond. And we double-checked if this was a coding issue. We double-checked if we messed up our models, but not. This is actually the case. And I'm happy to discuss this, but one idea that we're coming up with is that perhaps older adults who report having previously been the victims of crimes may be more aware of where their phones are, and maybe they pay more attention to them just in case they get in trouble again or something unexpected happens. So these prompt us to think, okay, so our response rate is not great, and also 21% of the people who said they were going to provide AMAs did not provide any. So these sort of made us think about, okay, so what did we actually miss? And when we analyzed the GPS characteristics of the people who provided some EMAs and those of the people who didn't provide any, what we saw is that people who were less likely to participate were more likely to spend time at home, travel lower distances, and be more exposed to lower income spaces. For our second research question, which was non-response, which again we defined as not answering a concrete EMA ping, that would be our why. And this is a multi-level model, and basically what we're doing is giving random intercepts to every unique respondent to account for the potential autocorrelation of their errors. And our main result from this model is that truly individual level characteristics are what's driving non-response the most, but we also see an interesting finding about the spaces or the context in which EMAs take place. So overall, the individual level characteristics go in the way that you would expect if you are fairly familiar with the literature on non-response in surveys. So we see that older adults from racial minorities are more likely to not respond in comparison to whites, and so it happens for male older adults and those who report a poor self-rated health. And again, here we see the same pattern that people or older adults who report having been the victims of crimes are less likely to not respond. Lastly, we see this coefficient of residential instability that, just to help you visualize this in terms of size, every 10% increase in the residential instability or residential turnover of a census tract is associated with a 0.02 increase in the probability of non-response. And how we're interpreting this is that older adults are less likely to provide responses in spaces that potentially have less familiar faces than what otherwise they would be comfortable with. So as a summary, we observed some similarities between non-response in EMA and traditional survey methods, but we also observed correlates of non-response that are unique to EMAs. And we think that unlike user-generated approaches like big data from Twitter or X, EMAs actually provide us with information about what we are missing, and we should be using that to our advantage to learn more about how it may be impacting our results and models. And we think that there needs to be a systematic effort to understand non-uptake, non-participation, non-response, and that could really improve, help study designs and maximize the information that we gather. Like if we think about Space Mapper and we imagine a scenario where people are really publishing results about this, how about we modify our algorithms that are triggering EMAs so they avoid certain spaces because we are really unlikely to gather data from them. Okay, that's everything. Those are some questions in case you're interested.